Okay, let's solve some free response questions. So looking at the first question on this assignment, it's a derivative graph one. First we're asked to find the values f of -6 and f of 5. And we're given an initial condition here, so we're feeling pretty good about that. Screen sketch. Cool. So I go to f of -2 equals 7, so we're 7 here. And then because the area of this box, or triangle rather, it's 4 by 2 and 1/2 base times height. This is an area of 4. So we're going up 4 from what the value we're at -6 to the value we are at -2, which is 7. So if we go up 4 and we end up at 7, we started at 3, and so that's f of -6. To find f of 5, I start from 7 here, and then I do all the stuff until I get to 5. So I subtract the area of the semicircle, which is 2 pi, 1/2 pi 2 squared. So I got 2 pi. And then I add the area of this thing, so this is 3 times 2 divided by 2, so that's 3, this area. And so I'm just doing 7 plus 3, or 10. And because this is below the axis, I do 10 minus 2 pi. All right, feeling good so far. On what intervals is f increasing? F is the antiderivative. This is the derivative graph. So increasing is just where it's positive. So that is from -6 to -2, and from 2 to 5. Find the absolute minimum. So it helps to find a whole bunch of points to do this, because you can prove it if you have a whole bunch of points. So I can say, I know this is 3. I know this is 7. I know this point here is 7 minus 2 pi. And I know this is 10 minus 2 pi. These are all the critical points and all the endpoints. And from this, I know that the smallest of these is 7 minus 2 pi. And so that is the minimum value. And my justification is from this. On the actual AP test, I would have made a table for this. But on the picture's fine, and if you do that on our test, that's fine. All right, now it's talking about some second derivative stuff. So it says find the second derivative at -5. So that's just the slope of the derivative. And so that thing has a slope of -1/2. Or explain why it does not exist. Okay. So that happens at 3. We see when x is 3, there is a cusp here. And so there's no second derivative. So we're like, cusp. So second derivative, I guess I should just call it f double prime of 3, is undefined. Q. And that's that question. All right, next one. Another derivative graph question. Back into the screen sketch. Oh, mistakes were made. Screen sketch, cool. All right. First thing we have to do is find g of 3, so this is similar to the first step on the other one we just did. And the way you do that in this one is because they give you this integral. You know, if you plug -3 in the top, it's a 0 width interval, or integral. So, booyah, I know I'm at 0 here. And now I gotta find the area of some triangles. This is a 3 by 4 divided by 2, so that's 6. This is 2 by 4 divided by 2, so that's 4. This triangle is 2 by 2, so 2. This triangle is 4 tall and 2 wide, so that is -4. Sick. Alright, I got all my triangles figured out. To find g of 3, easy money. I'm just going until I get here. Oh, I'm going to have to figure out another triangle. And here I thought I was done. So that's 2 times 1 times a half. Half base times height. So that triangle has a -1 area. I guess I should say it's -2 tall. So we're doing plus 10 minus 1, so that's 9 for g of 3. All right, next one. On which intervals is the graph of g both increasing and concave down? That means the value is positive and the slope of the graph is negative. And so from -5 to -3, we have positive value, negative slope. And from 0 until 2, we have positive value, negative slope. Sick. Next one, we have some quotient rule things, so let's do some quotient rule. So I get h prime of x equals bottom d top minus top d bottom over the bottom squared. And then we chuck a 3 in there. We get 15 times g prime of 3. So g prime is f. So I just look at what f is at 3, and I'm like, booyah, it's -2. And then I look -5. G of 3 is 9. We know that because, we did part A. And then we just are dividing by 25 times 9. 3 squared is 9. So we get -30, -75 over 225, or -1/3. And booyah. Almost done. All right, for D, I have some p function, so let's take the derivative of p, because we're finding its tangent. So p prime of x equals f prime of x squared minus x times 2x minus 1. Sick. All right. Now we just plug stuff into this. So I get p prime at what, -1 equals f prime, and -1 squared is 1 plus 1 is 2. F prime of 2. And then we plug in here and we get -3. Okay, so f prime of -2 is the slope of the graph, or f prime of +2 is the slope of the graph here at 2, which is a -2, that slope. So -2 times -3 is +6. But wait, there's more. Oh no, never mind. Slope of the tangent line, we're good to go. That's a 6. And that's that question. I love the answers here. They're like so friendly, like they look so short and nice. And I'll see you in the next video where I do the next 2 problems.